Thank you for the feedback. So we are here to present the P2012 Sentinel ISR Ethos, which is a product developed alongside with the Leonardo company, as has been introduced by Mr. Di Bartolo previously. A quick introduction of Tecnam. We are in business since the late 40s, founded by Giovanni and Luigi Pascale. Been producing aircraft since then. We've also been producing parts for Boeing 717, Alenia for the ATR, which we have seen earlier, Aermacchi and Augusta. And today, Tecnam is one of the most innovative and fastly growing companies. Gamma is assessing us with a global presence, 65 dealers, 265 service centers, top 3 manufacturers in the segment, and we are supporting more than 7,000 aircraft worldwide. Today we are presenting the P12 Sentinel ISR Ethos, which is the top of our current fleet that we currently produce. The Sentinel ISR Ethos developed alongside with the Leonardo company. We call it the Smart Piston Twin. It is a twin piston aircraft with turboprop capabilities, and at the same time coupled with the piston engine aircraft efficiency. 750 horsepower aircraft, roughly 200 knots maximum cruise, and almost 1,000 nautical mile range with a 1,400 kilogram payload. It is equipped with a Garmin G1000 NXI glass cockpit avionics system. It is certified for single pilot operation or a dual pilot, and is a state-of-the-art system for the category. It is truly a multi-mission aircraft. Of the several versions we manufacture, today we're going to talk specifically of the ISR Ethos, which is for the category a wide cabin aircraft with 5 crew members and 1 or 2 pilots, 2 sensor hatches, a heavy mission payload. It's capable of VFR, FR, and PBN operation. It's approved to fly in icing. It has a traffic avoidance system, air conditioning, weather radar, synthetic vision, autopilot. It's approved to fly on short field runway and unprepared runways. For the observe, orient, decide, and act, the Sentinel ISR Ethos is equipped with the reference configuration of the Gabbiano Ultralight TS-80 surveillance radar, coupled with the LEOS UAR AIS system and a mission operator console with the 2-screen keyboard and trackball. It can also be upgraded with several impressive growth capabilities to bring its capability very close to the CS-25 aircraft like the C-27J that we see on the picture, including Leak 16, SATCOM, several comms, higher UIR payload, E-scan radars, and many more systems. With enhanced HMI, advanced functionalities, and some new sensors. So this system is capable of providing basically the ISR solution to observe efficiently and gather valuable data. It provides an efficient mean by its low operating cost. We are seeing cost of operation in the range of $400, $450 or euro per hour. Pilots-wise, doesn't require type rating, everyone can fly it. From a mission operator point of view, it's a multi-mission aircraft, and the mission system can truly be tailored to the requirement for a mission. And from the technician point of view, it has been designed for rugged and durable design and very easy maintenance. Going to the potential scenario of South Africa, we can see that a fully optioned aircraft with the Ethos mission system will cover the entire country with a 780 nautical mile range, and most of its surrounding waters and neighbor country, and this is centered on Pretoria. I've also taken advantage of looking at some of the field, like the 121 Battalion Airstrip, King Shaka International, or Port Elizabeth or Easter Platte. And in those airfields, if we consider a 50 to 200 nautical mile offshore mission, we could stay on station between 5 to 7 hours, just 50 nautical miles offshore, up to 2 to 4 hours when we are flying 200 nautical miles offshore. And this is again a fully optional aircraft with reserve, a good payload, and the Ethos mission system carried on board. What are the benefits, potential benefits of a P2012 Sentinel equipped with the system, a powerful mission system and a customizable configuration? From the airframe point of view, low operating costs, low training requirements, low crew costs, low fuel consumption, and very, very high duty cycles for its design. Safety-wise, we are still looking at the twin engine, which achieved the latest safety certification. It has been certified in 2019 in EASA and FAA, and state-of-the-art avionics, latest released by Garmin. Low pollution, low noise, and small aircraft is always a nice to have, and an ongoing green transition. 1 or 2 pilots and up to 5 operators. It has air conditioning, which is nice, heating and venting, and a plus, which we all consider, considering that we are in the Italian embassy and talking for the Italian industry, modern, sleek, and advanced. I hope I stayed in the 5 minutes, and I thank you all, ladies and gentlemen. Thank the embassy and all of the audience.
Thank you, Prof. Let me take this moment to thank workshop organizers for inviting IMT to participate in the workshop. As Prof introduced me, my name is Tholo. I work for Institute for Maritime Technology within the domain of maritime domain awareness. Sorry, I just have to. Okay. This presentation will actually discuss IMT technology advances towards maritime domain awareness. And then it will also discuss Vista software suite suitable for land, border, and maritime surveillance. I will also touch base on big data. And then I will give a case of AIS case study, and also look at how AI can improve the decision making and prediction within maritime domain awareness using AIS data. Okay, the definition of MDA is effective understanding of anything associated with a maritime domain that could impact the security, safety, economy, or environmental of the nation. So in summary, actually, MDA involves gathering of information, data fusion, and informing the stakeholders for monitoring and of maritime activities. Okay, previous speakers have already highlighted the challenge that we have in our coastline. South Africa is one of the countries that have a long coastline, and with that we face so many challenges like in other countries. The crimes at sea, human trafficking, and as well as other crimes associated with the illegal fishing, and so on and so forth. So in the middle there, you can see that the vessel density map. You can see that South Africa actually is one of the busiest shipping lanes, and we have seen also with the issues that we have with at the Suez Canal, the traffic actually also increased. So our waters are one of the busiest. So similar thing happens with challenges at land. We have one of our borders are very large, and the challenges that we have there is the rain issues and not being able to detect a human. So this slide actually just highlight that protecting borders for illegal movement of people and drugs and other things becomes very important for our economy as well as our national sovereignty. So therefore, it is very important actually to protect our borders. And how we protect our borders. We need a border security surveillance system that can actually scan a wide area and then detect and possibly identify threats, intrusion, real time at night as well as at day, in all type of conditions. And over the years, IMT has actually developed a system called VistaNet, which consists of networks, networking and software modules, which are flexible to accommodate surveillance of any domain. It does have a sensor that can actually provide detection, identification, and then rules and alarm and alerts. Okay, this is a high-level system architecture of VistaNet. So on the left here, you have various sensors ranging from AIS, optical long-range cameras. You have a weather station for to provide environmental information, and we are able to integrate into drone camera to stream data back into control center. And then we also have IoT as one of the sensors that can actually control and monitor the life health of our sensors along the coast. And then that data is actually collected. And then through a visual private network, we are able to send into the central data center where we do a data processing and then track management. And then we have our set of rules. And the data is also shared with other government institutions, and we contribute to the integrated vessel tracking tool, which forms part of operational Pakisa, OSIM system. And the data is also distributed into maritime domain awareness centers, where actually they monitor various application and then the various using these sensors, and then they make a decisions. Our area of expertise, we include sensor site evaluations, best sensor sites, sensor recommendations, and we do digital integration of sensors and data sources, manage sensors, and develop various management tools, data management tools. Okay, the VistaNet system, as I highlighted, it was developed about 2 decades ago. It's a very mature system, and then it actually primarily was used to manage coastal network sensor data, and then it also it can also be expanded into land border systems, border environment. Okay, some of the key features of the VistaNet system it includes digital integration of sensors, such as radar, AIS, weather station, like I indicated, the electro-optical cameras, and then infrared cameras. And then we are able to provide a real-time display. And then also we are able to store data and play historical data for any event. It does have a built-in alarms, rules, and functionalities. And we are able to actually identify the target and slew to queue camera functionality, whereby we can actually assign that target to a camera and then so that for tracking purposes. It does support it's a distributed network architecture, whereby the data can be shared on a different node, whereby if one node goes down, the other can actually take over. Because of that feature, we are able to actually define a specific zone of interest or operation. So you can actually use a system separately for specific operations remotely without being dependent on a main server or being isolated from the entire network. Okay, the system does have rules functionality as well as alarms. We can define specific zones and set alarms, like for instance, maritime protected areas. We can detect the suspicious speeds of course, loitering, wanted vessels, collision behavior, and so on and so forth. However, we see AI algorithms bringing a very important role by actually looking at anomaly detection by fusing multiple data sources and other information such as open source information such as both news, social media, and so on and so forth. So this is just a typical wall video wall in one of the control centers. So on the left there, you can see that this is actually a Vista system where it has vessels, and then also we are able to see the air tracks, which actually these are just the airplane at the Cape Town airport. And at the bottom there, you will see that this is actually just optical camera at some of the key points. So in short, we are able actually to have all these multi-sensor sources and then distributed into this control room for decision making. Okay, so this is just a typical optical harbor camera system in one of the harbors. Okay, now just want to highlight the case of AIS big data challenges. As we know, the AIS is actually limited offshore coverage. It has a limited offshore coverage, and also the channels in some cases are congested. I know there is other systems that are next generation AIS, such as VHF data exchange systems, which could actually address the challenge. But those systems are still at the early stage. And also the problem of erroneous manual data input into the system, that becomes a challenge sometimes because it provides inaccurate information of the actual events. And non-secure channels leads to manipulation of the AIS data. For instance, the GPS spoofing. We have seen in many cases where the vessel actually report that they are we can see that it's at a certain location, but only find out actually they actually spoof their actual location and stuff. So that is one of the challenges. And storage, processing, and analytics of the data. That is also because the AIS data can be a challenge when it comes to storage and also processing real time or having to go back and look at what happens. And the AIS can just be switched off and people do any other illegal activities with the AIS by just switching their transponders off. So having said that, so we see the role of big data and AI as playing a major role in terms of addressing some of these AIS challenges. So from our side, we started looking at using what we call visual and AI algorithm for vessel estimate time of arrival prediction, whereby we look at the historical data, because the AIS provides us with their location. They can also provide us with their destination. So what we did, we built a prediction algorithm using the AI. And how we tested, we actually just look at, we can predict for a specific time and overlay that information with the real-time AIS, just to see if they are actually on that, where just to test our algorithm to see if they can be at the destination at a specific time. And yes, it is still a work in progress, but we believe that using the historical data and real-time data and taking the environmental factors into place, it could actually improve our algorithm. And then the other areas we're looking at using AI to analyze AI's big data, which could actually improve decision making, where the clients will actually be able to deploy assets at the right places, and then also provide indication of trade threats as well as maritime activity, improve port operation efficiency, and provide better surveillance and situation awareness. Okay, thank you very much for your attention.